Hello YouTube, this is Mr. Bakari, and today we're going to solve trig equations with period change. So let's look at what we mean by a period change. So what I've got here is three sine graphs. Okay, the one in red is the parent function, sine x. The one in green is sine of 3x. And in blue, we've got sine of x over 4. Okay. So what we're looking at here with the green and the blue functions are coefficients with our angles. Okay, so we haven't seen that up until now with the equations we've been solving. So when we multiply the variable by a number greater than 1, okay, greater than 1, like this one right here, 3, we're making the function complete its cycle faster. So that means the period gets smaller, so the graph is horizontally compressed. So as you can see, the green graph has been compressed in comparison to the red graph, which is the parent graph sine x. Okay, and so the opposite is true if we've got a coefficient that is between 0 and 1. Okay, so in the blue graph over here, this function right here, we've got 1/4 x. Okay, so that means we are horizontally stretching the graph. So if you look at the blue graph in comparison to the parent function, it has been stretched. Now, what does this mean in terms of solutions? Well, if I take the line y equals 1/2 right across here, along the interval that I've provided, highlighted in yellow, you can see this interval goes from negative pi to pi. Our red graph, our parent function, has two solutions. Okay, I'll mark those solutions for you right here and right here. Those are the two solutions of sine x, where sine x is 1/2 in the interval negative pi to pi. Now, if we look at the green graph, there are several solutions along the same interval, and that is due to the period change. Okay, that compression gave us more solutions. And then in the blue graph, we can see that sine of x over 4 equals 1/2 one time in that same interval. So we have less solutions. And so graphically, we can see what these period change do to our solutions. Okay? So now let's look at some functions and we're going to solve these algebraically. Okay, so our first one here, we are solving over the interval 0 to 3 pi over 2. So we always want to look at that first. First, to tell us, are we solving for angles in degrees or radians? Okay, so this is in radians. Now, if I look at this sine function, I can see the 2x. So I know this has been compressed horizontally. Okay, so I'm going to have to, when I solve these, I'm going to have to adjust our solutions to account for that change. So we will do that at the end. So right now, we're just going to solve this like we would any other. I'm going to isolate sine. So I'm going to subtract the square root of 3 and then divide by 2. And that will give me sine of 2, oops, sine of 2x equals negative square root of 3 over 2. So what I want to do is I want to find angles within one rotation, right? We're going to look, we call these our primary angles. We're going to look at one period of sine where sine is negative square root of 3 over 2. So I know sine is negative in quadrant 4 as well as quadrant 3. And sine is, of course, y over r. And so I can see that my reference angles here are 60 degrees, or in radians, that would be pi over 3. So my angles here are 4 pi over 3 and 5 pi over 3. Okay, so what I'm going to do is I'm going to set 2x equal to the first angle, 4 pi over 3, and 2x equal to the second angle, 5 pi over 3. Now, I am going to be looking for these along different intervals. So I want to add a period of sign, which is 2 pi n. N represents any integer, so I could add 2 pi or subtract 2 pi infinitely with integers. That's what that represents. So I'm going to do the same right here. Okay? Now, I have not solved for x yet because I've solved for 2x. I've got to get rid of the 2. So everything is going to get divided by 2. Okay? And when I do that, I get x, and then 4 pi over 3 divided by 2 is 4 pi over 6, plus 2 pi n over 2 is pi n. I'll do the same down here. 5 pi over 3 divided by 2 is 5 pi over 6. And 2 pi over n divided by 2 is pi n. Now, these are my solutions for all angles. But I'm not looking for all angles. I'm looking over this interval 0 to 3 pi over 2. So by adding pi or subtracting pi to these two angles, that's how I'll find all my solutions, okay? So I'm just going to put my solution set over here, x equals, and I'll look at my first primary angle here, 4 pi over 6. So 4 pi over 6 does fall in my interval here, so I'm good with that. Now, if I subtract pi from that, that will take me into the negative. So I can't do that. And if I add 4 pi over 6, that's going to take me larger than 3 pi over 2, which would exceed my interval. So I can't do that either. So I'm going to go to my second angle, which is 5 pi over 6, which does fall in the interval. And I believe the same is true. If I add pi or subtract pi from 5 pi over 6, that will not give me either way an angle in this interval. So these are my solutions, and I am done. Okay, so that's how it's done. So again, when you solve equations like these, you have to adjust your solutions to account for the change. Okay, so when we did that division step, that's what we were doing. All right, let's look at another one. Okay, so this one is tangent, and we are solving for 0 to 300 degrees. So now we're changing gears, going to degrees. And looking at this, I can see I've got a 3x. So this is going to be a horizontal compression. I'm going to isolate tangent by subtracting 2 and dividing by root 3. Okay? So I want to look for angles where tangent is -1 over root 3. So tangent is negative in quadrant 4 as well as quadrant 2. Tangent is y over x. Okay? So as you can see here, our reference angle is 30 degrees. Okay? So that and that are the angles I need. And those angles are, let's see, we've got, that's 30 degrees. We've got 150. So I'm going to take 3x equals 150 degrees plus a period of tangent. Now, a period of tangent is 180 degrees. You got to be careful there. N. And then I'm going to take 3x and set it equal to my other angle, which is 330 plus 180 degrees N. Okay, remember, tangent and cotangent have a period of pi or 180 degrees. So now I need to divide by 3. So I'm going to divide everything here by 3. And that will give me x equals 150 over 3 is 50 degrees plus 180 over 3 is 60 degrees N. So this is making those adjustments that I was talking about. And now we have solved for x for all angles, okay? So this is not our answer though. We have to look at this interval. So I'm going to take my first angle, which is 50 degrees, and 50 degrees does fall within my interval. Now, if I subtract 60, I'm in the negative. So I can't subtract, but I can add it. 50 and 60 is 110, which is another angle, another solution in that interval. And then if I add 60 again, I get 170 degrees, which is in that interval. I can go ahead and add it again. It gives me 230. And one more time for 290. I can't add 60 after that. I'll exceed 300 degrees. Okay. So I have to stop there. Now, my second angle here, 110, is already written right there, and I've added 60 to it. I'm good. Those are all my solutions, and I am done. Okay? All right, let's look at another one. This one is in degrees as well. We're looking at angles between negative 180 and 360 degrees. All right, I've got cosine. This time I've got a horizontal stretch. I got a fraction in there, okay? So this is pulling the graph away from the y-axis. So what that means is I should see fewer solutions here. So let's see what happens. I'm going to isolate cosine by dividing by 2 root 3. Okay, so that's 3 over 2 root 3 equals cosine x over 2. Okay, so I'm looking for where cosine is positive, right? So cosine is positive on the right-hand side, quadrant 1 and 4. And I've got cosine, which is x, and r, which puts that square root of 3, which makes my reference angles here 30. Okay, so 30 degrees. So that means x over 2, my first primary angle here, equals 30 degrees. And this one is 30 degrees shy of a full rotation, which is 330. Okay? And of course, I've got to add a period of cosine, which will be 360n, 360n. Okay? All right. So now, let's see, we've got to multiply by the reciprocal here, right? 1/2. So I'm going to multiply everything by 2. All right. Multiply everything by 2, adjust my angles, and that's going to give me x equals 60 degrees plus 720 degrees, and x equals 660 degrees plus 720 degrees. And those are my solutions for all angles. Now let's look at the interval at hand, which is negative 180 to 360. Okay? So again, I will start with my first angle here, which is 60 degrees, which falls into the interval. I'm going to subtract 720, but I'm not going to do that because look, if I subtract 720, that's going to take me way into the negative. So I can't do that. And if I add 720, that's not going to work as well because I will exceed the top here at 360. Okay? So looking at my next angle down here, 660, 660 does not fall in either in this as well. So if I subtract 720, what's that going to give me? That would give me negative 60 degrees. And negative 60 degrees does fall within our interval. So that does work. So that's as far as I can go. And like I said, we're probably going to just have a few angles here because this has been stretched. So there we go. 60 and negative 60 degrees are the solutions over the interval negative 180 to 360. All right, we're going to look at one more here. So this one is again in degrees. Okay. We have a square. We have cosine squared here. So I want to isolate that square, and we take the square root of that. So it looks like that's the strategy here. I'm going to add 3 and divide by 2, which leaves me cosine squared 2/3 x. Okay? So now I'm going to go ahead and take the square root of both sides, and that will give me cosine 2/3 x equals plus or minus 1 over root 2. Okay? So I'm looking for all angles where cosine is positive and negative. So I'm looking at all 4 quadrants here. Draw a triangle in all 4 quadrants. Okay, on these videos, when we're looking for exact solutions like this using the unit circle, I don't want to assume anybody is memorized sine and cosine on the unit circle, so I like to draw the triangles out. So that's what we're doing here. So cosine is x over r, and I've got 45s all the way around. And I'm looking at degrees. So 45s all the way around. I'm going to write small here because we've got a lot to do here. We've got 2x over 3 equals, my first primary angle here is 45 degrees, plus period of cosine 360 n. Okay, next I've got the second quadrant. What angle is that? 135 degrees plus 360 n. Okay, and our angle in the third quadrant is 225. Got a lot of angles here. And then the fourth quadrant, we've got, let's see, 315, right? Yeah, 315. Okay, so now to solve for x, we got to multiply by the reciprocal of 2/3. So everything here is going to get multiplied by 3/2. Okay, 3/2 to every term here. I'm going to shortcut this just to show everything here gets multiplied by 3/2. All right, you want to take your time with this, okay? Maybe pick up a calculator. Let's figure this out. When I multiply by 3/2, I get x equals 45 times 3 divided by 2 is 67.5 degrees. Okay? Plus 360 times 3 divided by 2 is 540 degrees. All right. Next here, 135 times 3/2, we get 202.5 degrees plus 540 n. And then we've got 225 times 3 divided by 2, which gives us 337 degrees, 0.5 plus 540 n. All right, one more here. 315 times 3 divided by 2 is 472.5 plus 540 n. Okay, so these are our solutions for all angles. Now let's look at our interval. It is between 0 and 360. So one rotation, okay? So 67.5 falls in that interval. Obviously, I'm not subtracting 540. Now, if I add 540, that's not going to work either because I'm going to 360. So then my next angle is 202.5. Again, I can't add or subtract anything there. 337.5. Does that fall into the interval? Yes, just barely, 360. I can't add or subtract anything there. And then the last angle, 472.5, exceeds our interval, which is 0 to 360, right? So we are going to exclude that from our solution set, which means we only have one, two, three angles here, and we are done. Wow, that was a lot of work. Okay, so it can be a little tedious. You just got to stick with it. But as you can see, the steps are the same. Okay, when you're solving these period change problems, you just have to make that small adjustment and then apply it to the interval that you're being asked to solve over. Okay? So I hope this has helped you with solving trig equations, and I'll see you next time.